Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in our physics playlist, in our lesson optics, we'll study reflection from spherical mirrors. In this learning video, we'll understand the concept of reflection and understand the image formation in both convex and concave spherical mirrors. So let's start reflection from spherical mirrors. When an incident light ray strike a plane polished surface and come back in the same direction, then this phenomena is called reflection of light. And the surface from which the light get reflected is known as reflecting surface. This phenomena of reflection is responsible for us to see the things around us by our eyes. When light falls on an object, the reflected light from object enters in our eyes and our brain process the image formed in our eyes and we can see or understand the final image. Now this reflection from any plane surface or curved surface is based on two laws, and those two laws are known as law of reflection. The first law of reflection states that incident light ray when reflects from reflecting plane and goes as reflected ray, both incident and reflected ray make some angle with normal to the reflecting surface, and these angles are known as angle of incident made by incident ray with normal to the surface and angle of reflection made by reflected ray with normal to the reflecting surface. And as per first law of reflection, angle of incident and angle of reflection, both angles are equal to each other. The second law of reflection states that the incident ray, the reflected ray and normal to the surface, all three should lie in the same plane. Depending on the position of object and on the shape of reflecting surface, whether it is a plane polished reflecting surface or a spherical reflecting surface, the nature of image formed will vary. Usual household mirror are plane mirrors. On a plane mirror, when a person look at his image in a plane mirror, the light rays from body get reflected from mirror, and for a person light appears to be coming along the straight line from a far away position and the tip of head is visualized here. Similarly, from toe the light coming to eyes appears to be coming along this straight backward projected position, and one will find his or her image at the same distance from mirror in the back side with the same size in the same direction as it is visualized in this diagram. Spherical mirrors are part of an imaginary circle and its reflecting surface is either curved inward or is curved outward. Now the spherical mirror with inward curved reflecting surfaces are known as concave mirror, and concave mirror are used as a saving mirror, whereas spherical mirror with outward curved reflecting surface are known as convex mirror, and such convex mirror are used as a side mirror for a vehicle to visualize large surrounding area of the back. The spherical mirror with inward curved reflecting surface is known as concave mirror, and when parallel light beam strikes such concave mirror, the light rays converge at a single point known as focal point of this mirror, and that's why these type of concave mirror are also known as converging mirrors. Convex mirror are those spherical mirrors with their reflecting surface curved outward, and parallel light beam get diverted from these mirrors, and that's why they are called as diverging mirror, and image formed by such convex mirror are erect, virtual and diminishing in size. That's why they are used in side mirror of vehicle to visualize large surrounding space of traffic area behind the vehicle. So we can say for a concave mirror, the reflecting spherical surface area is curved inner side, whereas for convex mirror, the reflecting spherical curved area is outward side, and parallel light beams converge for concave mirror. So concave mirror is a converging mirror and for convex mirror they diverge as it is illustrated in these drawings. As said earlier, the reflecting surface of a spherical mirror is a part of sphere, and center of that sphere is called as center of curvature, and center of curvature is represented by capital C letter, and distance between center of curvature and any point on spherical mirror is known as radius of curvature, denoted by capital R. The middle point of this spherical mirror, whether it is concave mirror or convex mirror, is called as pole of mirror, and pole is represented by letter capital P. If we connect pole and center of curvature and generate an imaginary axis, then that axis is known as principal axis of this spherical mirror, and this length of reflecting surface over which parallel light beams falls is known as aperture of mirror. So this is aperture of mirror, and this is principal axis of convex mirror, and this is principal axis of concave mirror. All the light rays which are coming parallel to the principal axis of either concave mirror or convex mirror, after reflection from spherical mirror, either they pass through or it appears to that after reflection they are passing through the single point, and that single point is known as principal focus of concave mirror or convex mirror, and this principal focus is denoted by capital F letter as it is indicated for both concave mirror and convex mirror. The distance between pole and principal focus is known as focal length of spherical mirror, and it is half of radius of curvature for both concave mirror and convex mirror. The rays of light from object after reflecting from the spherical surface meet at a point and form an image of that object, and for image formation by spherical mirrors we have to use certain rules, and there are 4 following rules to find out formation of image by spherical mirrors. The one rule is ray which are coming parallel to principal axis, where principal axis is imaginary line joining pole and center of curvature, and all light rays coming parallel to principal axis after reflection pass through the principal focus in case of concave mirror, and they looks coming from principal focus of convex mirror. Similarly, rays of light coming from object and passing through focus after reflection from spherical mirror will pass parallel to principal axis as shown by these brown light rays at incident position to mirror, and after reflection parallel to principal axis as incident passing through focus, and after reflection from mirror parallel to principal axis. So incident light ray parallel to principal axis after reflection passes through principal focus, and similarly incident ray passing through focus after reflection moves parallel to principal axis. For image formation by spherical mirror we also use 2 additional rules. One is a light ray passing through the center of curvature of this spherical mirror after reflection retrace its path as shown by this black incident ray reflected back on the same track passing through center of curvature again. And if a incident ray incident at pole, then angle of incident with principal axis and angle of reflection from principal axis will be the same. So it will be reflected at the same angle as by it is incident with principal axis. The nature, size and orientation of image formed by a concave mirror depends on object position in front of concave mirror, and depending upon object position the image formed may vary, and if object is kept at infinity then light ray from that object comes as parallel to principal axis, and in that case all reflected rays will converge at principal focus and will get a real inverted and highly diminishing, just like a point-sized image located at principal focus. If object is kept between infinity and center of curvature, then image can be formed by meeting position of two reflected rays, one parallel to principal axis passes through focus and passes like this, and the other incident light ray from focus after reflection from mirror passes parallel to principal axis and they meet here. So image is formed between focus and center of curvature, and this image is real, can be obtained on screen, and inverted diminishing in size, that is smaller in size compared to object as shown in this diagram. So when object was at infinity, image was at focus and very small in size, and when object moves towards center of curvature from infinity, inverted image get enlarged and moves towards center of curvature. And if we move object up to center of curvature, then we'll find that its image will be formed again at center of curvature, and the two object and image are of same size but inverted from each other. So when object is at center of curvature, it will form a same size inverted image of object at center of curvature. So from pole, both object and image got same distance position. If we further move the object towards pole and kept it between center of curvature and focus point, then its image will increase in size and will get a real inverted image larger than object between center of curvature and infinity as shown here. And the largest real inverted image is possible when object is located at focus, and in that case a very large size image is formed at infinity from this concave mirror. And if object is further moved towards pole and it is kept between focus and pole, then it will produce a virtual upright image that is located behind the surface of mirror as shown here. The incident ray parallel to principal axis after reflection passes through principal focus, and when we revert it, it meets the other ray passing through center of curvature and reverting back at this position, and that will form a image which is virtual, cannot be produced on screen, upright and enlarged. And this particular phenomena is used in shaving mirror or dentist mirror to see enlarged upright image of any object near mirror. Convex mirror is a diverging mirror and its reflecting surface is curved outward, and depending upon position of object in front of convex mirror, the nature, size and orientation of image is formed. And if object is kept at infinity, then light ray comes parallel to principal axis and they after reflection virtually comes from principal focus which is behind the mirror, and we get a virtual erect and highly diminished point sized image at focus as shown here. A convex mirror always produces a upright virtual image behind the mirror for any position of object, and if object is kept between pole and infinity, then its image are formed as parallel to principal axis after reflection appears to be coming from principal focus, that is backside of mirror as shown here, and the incident ray towards principal focus after reflection passes parallel to principal axis, and when we project it back it meets here, and that would be the position of image. So for an object we will get virtual, erect and diminished size image for every position of object between infinity and pole for such convex mirrors. And this particular characteristic of convex mirror is used as side mirror of vehicle, and we can visualize large space behind vehicle in a small visible mirror position by diminished, erect, virtual image in mirror. We hope this small learning video has explained both concave spherical mirror and convex spherical mirror, and you could now understand how reflection from these spherical mirror takes place. And with this concept you can also form image for any object placed anywhere between infinity and pole for both concave spherical mirror and convex spherical mirror. Our other learning video of the same playlist are equally useful. You can use them in your study or refer them to your friends. And if you need exam-centric dedicated notes from our channel or like to join our online learning classes, do join membership of this Shridevi Classes YouTube channel. Happy learning. Have nice time. Thank you very much.